diving into the Neet UG 2026 syllabus. It's quite the comprehensive roadmap for medical aspirants in India, covering physics, chemistry, and biology in depth.
Yeah, absolutely. It's, not just a list of topics, but a carefully structured curriculum that really tests a deep understanding of both fundamental and applied sciences. It's designed to build knowledge progressively, right?
Exactly. And what I find interesting is how the syllabus integrates theory with practical skills, especially in physics and chemistry. It's not just about memorizing facts, but really grasping concepts and applying them.
Right, and for this episode, we're aiming to give an expert-level overview, highlighting the key topics and insights that define the exam's scope and depth. So let's start with physics.
Sure. Physics is divided into 20 units, starting from the basics of measurement and going all the way to electronic devices and nuclear physics. The first unit, Physics and Measurement, covers fundamental concepts like SI units, dimensional analysis, and error analysis.
Yeah, that unit is crucial because it sets the foundation for how physical quantities are measured and analyzed. Understanding significant figures, least count, and errors is essential before you even get into the mechanics.
Absolutely. Then units 2 through 5 focus on mechanics, kinematics, laws of motion, work energy power, and rotational motion. These build a strong classical mechanics foundation.
And what's great is the emphasis on both conceptual understanding and mathematical formulation, like vector resolution, torque, moment of inertia. These aren't just abstract ideas, but tools to solve real problems.
Right, and the syllabus covers projectile motion, uniform circular motion, Newton's laws, conservation of momentum, and rotational dynamics. It's quite comprehensive.
I noticed that the rotational motion unit also compares linear and rotational motions, which is a nice touch. It helps students see the parallels and differences clearly.
Yeah, that comparison is often overlooked, but really important. Moving on, Unit 6 covers gravitation, universal gravitation, Kepler's laws, satellite motion, escape velocity.
That's where classical mechanics meets astrophysics, which is always fascinating. It's interesting how the syllabus links these concepts to real-world phenomena, like satellite orbits.
Exactly. Then Units 7 to 9 cover properties of matter and thermodynamics, elasticity, fluid mechanics, viscosity, surface tension, heat, thermodynamics laws, and kinetic theory of gases.
The inclusion of Bernoulli's principle and critical velocity in fluid dynamics is particularly noteworthy. It shows the syllabus's focus on applications, not just theory.
Yeah, and the kinetic theory unit ties microscopic molecular behavior to macroscopic properties like pressure and temperature, which is a key conceptual bridge.
Then units 10 to 12 cover oscillations, waves, electrostatics, and current electricity. Simple harmonic motion, wave phenomena, electric charges, fields, capacitors, Ohm's law, circuit analysis.
The balance between theory and practical circuit laws like Kirchhoff's and Wheatstone Bridge is well maintained here. It's essential for students to understand both.
Definitely. Units 13 to 15 focus on magnetism and electromagnetic induction, Biot-Savart law, Ampere's law, electromagnetic induction, AC circuits, transformers, and electromagnetic waves.
I like how the syllabus covers fundamental laws and their real-world applications, like transformers and AC generation. It's not just abstract physics.
Then units 16 to 19 cover optics, dual nature of matter, atoms and nuclei, and electronic devices. Reflection, refraction, wave optics, photoelectric effect, Bohr model, nuclear physics, semiconductors, diodes, logic gates.
The inclusion of quantum concepts and modern electronics really broadens the syllabus's scope. It's a good mix of classical and modern physics.
And finally, Unit 20 is all about experimental skills. Practical experiments from measurement techniques like vernier calipers and screw gauges to electrical circuits and optics.
That's so important because hands-on skills reinforce theoretical understanding. It's great to see practicals integrated into the syllabus.
Absolutely. So, Liam, moving on to chemistry, it's divided into physical, inorganic, and organic sections, each with detailed units.
Right. Starting with physical chemistry. The basics cover atomic theory, mole concept, stoichiometry, the essentials.
Then atomic structure dives into quantum mechanics basics, Bohr model, quantum numbers, orbital shapes, electron configuration, and principles like Pauli's exclusion and Hund's rule.
That's a solid integration of classical and quantum views of the atom. It's quite detailed.
The chemical bonding unit is also rich. Ionic, covalent, metallic bonding, VSEPR theory, hybridization, molecular orbital theory, resonance, hydrogen bonding.
The molecular orbital theory inclusion is significant because it goes beyond simple Lewis structures, giving a more accurate picture of bonding.
Then thermodynamics and solutions cover the first and second laws: enthalpy, entropy, Gibbs free energy, colligative properties, Raoult's law.
I like the emphasis on spontaneity criteria and equilibrium constants here. It's fundamental for understanding chemical reactions.
Equilibrium and electrochemistry units cover chemical and ionic equilibria, acid-base concepts, redox reactions, electrochemical cells, and the Nernst equation.
And chemical kinetics rounds out physical chemistry with reaction rates, order, molecularity, Arrhenius theory, and activation energy.
Moving to inorganic chemistry, the periodic table and periodicity unit covers trends in atomic and ionic radii, ionization enthalpy, electron affinity.
Then p-block elements cover groups 13 to 18, their properties, and unique behaviors.
The D and F block elements unit covers transition metals, lanthanoids, actinoids, their electronic configurations, properties, and important compounds like potassium permanganate.
Coordination compounds are also covered: Werner's theory, ligands, coordination number, isomerism, bonding theories including crystal field theory, and applications.
Coordination chemistry's inclusion reflects its importance in bioinorganic and industrial chemistry, which is great.
Organic chemistry starts with purification and characterization techniques, crystallization, chromatography, elemental analysis.
Then basic principles cover hybridization, functional groups, isomerism, reaction mechanisms like substitution, addition, elimination.
Hydrocarbons include alkanes, alkenes, alkenes, aromatic compounds, their reactions and mechanisms.
Compounds containing halogens, oxygen, and nitrogen cover preparation, properties, mechanisms, and environmental impact.
The biomolecules unit covers carbohydrates, proteins, nucleic acids, vitamins, and hormones, linking organic chemistry to biology.
Practical chemistry includes detection of elements and functional groups, preparation of inorganic and organic compounds, titrometric exercises, and qualitative salt analysis.
It's a well-rounded syllabus that integrates theory with practical skills.
Definitely. Now, biology is structured into 10 units covering diversity, structure, physiology, reproduction, genetics, biotechnology, and ecology.
The first unit on diversity covers classification systems, taxonomy, 5 kingdoms, and salient features of major groups of plants and animals.
It balances classical taxonomy with modern systematics, which is important for a comprehensive understanding.
Structural organization covers morphology and anatomy of plants and animals, tissues, and organ systems.
Cell structure and function covers cell theory, prokaryotic and eukaryotic cells, organelles, biomolecules, enzymes, and cell division.
Plant physiology includes photosynthesis with C3 and C4 pathways, respiration, and plant growth regulators.
The inclusion of the chemiosmotic hypothesis and photorespiration shows the syllabus's depth.
Human physiology covers respiratory, circulatory, excretory, locomotion, nervous, and endocrine systems, including disorders and diseases.
It's great that the syllabus covers both normal function and common disorders, emphasizing clinical relevance.
Reproduction covers sexual reproduction in plants and humans, gametogenesis, menstrual cycle, fertilization, pregnancy, reproductive health, contraception, and assisted reproductive technologies.
Genetics and evolution include Mendelian inheritance, molecular basis of inheritance, DNA structure and replication, gene expression, evolution theories, and human evolution.
The inclusion of modern genetics concepts like the lac operon and the Human Genome Project is quite forward-looking.
Biology and human welfare covers diseases, immunology, microbes, in industry and environment.
Biotechnology covers genetic engineering, GMOs, and biosafety.
And finally, ecology and environment covers population dynamics, ecosystems, biodiversity, and conservation.
It's a holistic syllabus linking biology to health and environment, which is essential for medical aspirants.
So Liam, to wrap up, what do you think are the key takeaways from this syllabus?
Well, I'd say the syllabus strikes a fine balance between classical concepts and modern scientific advances, theory and practical skills, and breadth and depth across all three subjects.
Yeah, and it really encourages a deep understanding rather than rote learning, which is crucial for future medical professionals.
Exactly. It's a roadmap for mastering foundational and advanced concepts essential for medical studies.
And it reflects the evolving nature of science education, blending depth with application.
Well said. I think listeners with a solid background will appreciate the syllabus's comprehensive and integrated approach.
Definitely. It's a challenging but rewarding curriculum that prepares students well for the demands of medical education.
So that's our overview of the Neet UG 2026 syllabus. Thanks for joining me in this deep dive.
Thanks, Liam. It was great unpacking this together.
Until next time.
Take care.